question 5 gives us an f of x equation to start with and wants us to find the derivative. So we were just doing a bunch of stuff with antiderivatives, and now we're jumping back into the world of derivatives again. And what we're looking at here is two special case derivatives that we need to know for this exam. The first special case that we're going to run into will be for the natural log there. So anytime I've got the natural log of x, the derivative of the natural log of x would be 1 over x. The thing to note here is as soon as that is anything more than just an x, so negative x, 3x, anything more than just a simple x, it's a chain rule problem. So that means we'll end up having to use our chain rule, which is our d in, d out game. So that special case is what we're seeing up in the front here with the natural log piece. And then the second special case that we'll have to worry about is for e to the x. So if I have an equation with e to the x in it, the derivative of e to the x would be e to the x. Again, just like with the natural log, as soon as there's anything more than just an x sitting up in that exponent there, this is going to become a chain rule problem. So that being said, we better write out our chain rule right now. So our chain rule, or at least my chain rule saying, is d in, d out, the derivative of the inside times the derivative of the outside. So when I come to look at that first piece there, the natural log, and I say to myself, what's my in and what's my out, so I can grab those derivative pieces, my inside piece would be all the stuff that I plugged inside that natural log. So that's going to be 5x squared plus 2x minus 1. The outside is just going to be the natural log of a bunch of junk. So the d in right now would just be a power rule. We'll bring that 2 down. 2 times 5 gives us 10x. And then a number times x to just a single power leaves the number, and the x drops off, and then the negative 1 is a constant. The d out here is just a normal natural log. It would be 1 over whatever was just on the inside. So for us, this would have been 1 over 5x squared plus 2x minus 1. That's going to be the d in, d out for that first chunk. And then if we do the same thing for our e to the x here, our in this situation would be the 6x. Our out in this situation would be e to a bunch of stuff. So the d in for us on that would be derivative of 6x, the derivative of a number times x will just be 6. And the d out is going to be just staying the exact same, so e to a bunch of junk. So that 6x would stay up in there. So now if we want to go ahead and put all of this together to get ourselves our final answer here, pulling together all of our pieces to grab our f prime of x, well, we're doing first a chain rule on this natural log. So again, the chain rule says go grab d in. So the d in here would be 10x plus 2. The d out would be 1 over, and then all the stuff that was on the inside there. So that's the derivative of the first piece. And then plus, we'll do a d in, d out on the e, because it also was a chain rule. So d in is 6, and then the d out would be e to the 6x. So that's our answer. And if we go over to look at the options that they've provided us, really we're looking at option A right now. All they really did was bring this 10x plus 2 that we had out in front. They just slid it onto the top right here. But we can see our 6e to the 6x sitting at the back, so we know that that's what we're looking for. So anything that didn't have that wasn't going to be right. So A is our right answer in this situation.